Okay. All right. I'd like to thank everybody for being here. My name's Craig. I'm KD6PN. This is all the ARRL stuff. I don't know why they just don't standardize it. This is actually block 0. So in your testing, so it'll be all the T0 questions and everything. There's only 2 questions on this part. This is electrical safety. And this is actually pretty logical stuff about being safe about electricity.
Can you go ahead and give us the test question?
The 2 questions are? I wish I knew what the 2 questions are, but we're going to go over all those questions. Okay, so here we go. All right, here. All right, we're talking about electrical injuries. What happens when electricity goes through your body is there's always an in and out. So you have to make 2 connections. A lot of electricians will tell you that the way you stay safe is keep one hand in your pocket. That's a way to do it and everything. And when you get up into high current, it actually destroys tissue. And I've seen actually pictures of people that get electrocuted on power lines and stuff like that, that it actually makes a char through their body and stuff. So these small amounts, you can just barely feel. So we're not about worried about that and everything. We have to start getting up into bigger areas here and stuff like that. We're talking about 10 amps here and 1 to 4 amps and stuff like that. This is just a general chart. They don't ask you any questions on that. Low voltages, you feel a tingle and stuff like that. Yeah, fortunately, we don't have such high power levels anymore in our radios, except for power amplifiers on HF. HF will have high power systems. Yeah, just don't touch anything. That's the big key thing. I'm sure there's going to be a test question on that. Just unplug everything before you work on it. Keep a hand in your pocket. Make sure the equipment is grounded. That'll be the metal chassis, that it's all grounded, and it goes to the green wire on your power plug and everything. You have GFCI circuits in your home. You're supposed to have them now in your garage and your bathrooms. Kitchen areas are all supposed to have them and stuff. And what that does is that's an electronic circuit that watches the power level. And if it sees a sudden surge on one side of the circuit, it disconnects it. So it's a pretty thing. It's not a cure-all for everything, but it's pretty good. Let's get through this pretty fast here. Oh yeah, watch out for jewelry. I had a guy working on his car, and you wouldn't think a car battery would be that dangerous, but he touched his ring finger to the battery of a car, and it cooked his finger like a hot dog and everything. So yeah, there's a lot of current that flows through our car battery. This is all just common stuff here. Okay, a safety interlock. Some equipment, especially HF power transformers, when you open the lid, you'll see it has a switch. And what it's doing is when you open it, it disconnects the power. Well, don't ever bypass that. That's a mechanical, electrical safety to make sure it disconnects the power. Don't bypass that. I think that's right. That's exactly right. There's a switch that shuts it off when you remove the panel. That's right. And then I think there's a question about the capacitors. Oh, store power even though the power is off, because you found that you remember the definition of a capacitor is to store energy, kind of like a battery and everything. And so what you may have to do if you're working in there is you'll have to ground those capacitors out to have them discharge. Storage batteries, okay. If any of you have solar panels, you've got high current batteries that the solar panel is feeding. Those things, even though they're low voltage, usually 24 volt systems, so they deliver a lot of current. Yeah, remove the power. Call for help, yeah. Whenever you have a a person work on electrical circuit on power lines, they have a lockout switch and they have to post it. You know, you see the yellow sign hanging down, you know, that it's shut off. Okay. An extra wiring for all your radio stuff. If you get the radio disease real bad, you'll want to start getting thousands of watts of electrical stuff in your room and everything like that. Make sure it's all the code. Just don't start using extension cords. You of course use a 3-wire power cord, which means it's a grounded cord. Circuit breakers. Remember the old fuses that you used to put, that used to be a screw-in glass type? My dad was famous for when one would blow, he put a penny in there. Yeah. Even as a kid, I thought that was kind of weird. It's amazing we didn't have Osborne now. Thank God those all got replaced. He finally sprung for the money and that whole panel was replaced with modern circuit breakers. Yeah, if you'll get an RF burn. Sometimes if the SWR is too high, when I was in high school and always fooling around with RF circuits and stuff like that, you get RF that comes back on the transmission line and you'll get burns off the transmitter and everything. But it's weird. Ground everything together. You're using heavy copper wiring or braid. Keep people away from antennas. There's one of the test questions is that it shows an antenna sitting on a lawn, and they're going to ask you, is that safe? Well, of course not, because if you're transmitting, a kid could go up and touch it, or maybe your dog touches it with his nose or something. So, pardon me? Sitting on a lawn. Just in a stake on a lawn. It's one of the questions. It's a picture of an antenna on a stake on a lawn. It's not safe. You know, it has to be up high enough so nobody can reach it. So nobody can grab onto it. Lightning protection. They got that power station up by Salt Lake that's been there 100 years, and it's got a old ground thing, lightning rod thing, something like that, and it's been hit like 500 times or something like that. Everything, all the bricks all spalled and stuff like that. I go, holy smoke. You wouldn't want to be anywhere near that thing in a thunder electrical storm. Yeah, make sure everything's grounded. Okay, this is a test question. I know 8-foot ground for each tower leg. That's the code. You can use heavy duty copper wire to go to each one. Well, we're going to review the questions, so don't worry about it too much at this point. Bond rods to tower leg and the other rods, so everything gets connected together. Ground connection short as possible. I think it's not supposed to have any right angles either. I think it's all supposed to go and everything. Can you use aluminum for ground wire?
Use what?
Aluminum.
Yeah, as long as it's not buried.
Yes.
Yeah.
If it's up in the air, you probably could. If below ground, you could.
Yeah, it'll just oxidize away. Yeah. Lightning arresters. Lightning arresters are all they are is 2 points that are spaced apart like this. So they don't short your antenna cable out or whatever the antenna connection is, but it's small enough of a gap that the lightning can arc across it. But that'll be a lightning arrestor. Okay. Yeah, you better believe that when the lightning storm hits, I start unplugging stuff. I start pulling the antenna connections off everything and stuff like that. The best idea is just to have a switch where it grounds everything for you. RF exposure. Yeah, everybody gets mixed up that EMF radiation, which is the radiation you get from your antenna, is the same as a radioactive thing. It's not. It's trying to microwave you is what it's doing. It warms you up. Fortunately, most ham radio stuff is pretty low power. So it doesn't really affect you. It's like the guy that invented the microwave oven. He was some kind of a microwave technician and he got in front of a microwave dish and it melted the Snickers bar in his pocket. And that gave him the idea that, hey, I can make a radar range, a Mana radar range out of that. Yeah, this is important. This is a real key thing to remember. RF absorption, which is the amount of energy that you absorb, it depends on the frequency because of your body size. We're going to go over that a little bit better. Okay, so it shows you that for most HF stuff, we don't have to worry about it too much and everything. This is the amount of time that you can be exposed to it without it actually hurting you. If you notice, this is the vulnerable area in here where this is the least amount of exposure you should get. And then as it gets up into microwaves, you can kind of take a little bit more. So the big primary thing is 6 meters. The question is going to be on 6 meters, 54 megahertz. And the reason why that is because the quarter wavelength for a 6 meter antenna is about 6 feet. Well, we happen to be about 6 feet long, so we're actually right the physical size of a quarter wave antenna for 6 meters. So they're going to want you to keep the power levels low on 6 meters. That's the only really dangerous frequency range. Nobody else hardly uses 6 meters anyway, but I don't have any 6 meter repeaters around here. But that's going to be the question. It's going to be about, but I think you can still go up to a couple hundred watts safely. The power levels are all pretty high for this stuff. Anyway, there's one question on that in there somewhere. Okay. Controlling the environment. Put your antenna up on your roof or behind fences or something like that, or on top of your car, something like that, so people can't touch it, can't grab it. So you control the environment. If you have no control over the environment, people get near your antenna and things like that, you're going to have to keep the power levels real low. You can't control especially your dog. You know, I don't know how many times my dog has hit the fence charger for the cattle next door. He starts walking around it and I tell him, don't get near that fence. You know better than get near that fence. And he'll like go under it and come back and go under it and come back. And then one time his tail hit it, you know, he gets a big cough. And then he stays, okay, he stays by me now. Oh, well, so you had to learn it again. Huh? All right, so they're going to talk about duty cycle, which is the amount of time that you're going to transmit. Yeah, this little formula thing in here. And basically, you can get more power if the duty cycle is lower, right? If you're only transmitting short periods of time, you can get more exposure to RF energy. Okay? If it's a very low level, you can transmit a lot because it's not going to matter anyway. So you're trading off one to the other. There's time of exposure and the power level. There's a balance between the two. Okay? This is going to talk more about the duty cycle here. This is how much, you don't need to memorize that stuff, but if some modes of transmission, sideband, FM, which is your handheld radios and stuff like that, Morse code and everything, it says it's so come a level of the duty cycle for those type of things. If you're transmitting amateur television, it's 100% duty cycle. Anyway, so it just shows, that's just the chart, so you're familiar with it. They're telling you here that you should perform an exposure evaluation. This is only if you're running large amounts of power, more than 100 watts and at least like 300 to 500 watts. Everything, should you do an exposure thing. You don't want it to be that, you know, you're exposing your kids or the kids next door and that kind of stuff. So lower power levels, no evaluation is required. So for your VHF, UHF antenna systems, ones in your car, things like that, you don't have to worry about it. Those are all like 25 watt systems. Yeah, well, it may be that it's in a dangerous spot, so you got to relocate it. Raise it up higher, which is always a good idea. if you, something like just 10 feet over the roof of your house, if you just get 10 feet over there, it has like a 3 dB gain, double signal. Yeah, you can reduce your power output, but you're trying to get somewhere, you're trying to do something. Lower duty cycle mode, yeah, maybe change that. Mobile safety, just watch where your antennas put, stuff like that. If you have your kid in a car seat, don't put the mag mount on his chair or something. Oh yeah, this actually kind of brings up a point, is that you may get stopped by the police because he'll think you're talking on your cell phone. And there's been several court cases that have ruled that amateur radio is not restricted like cell phone use inside of a car. So what I suggest, which is what I do, is I keep a copy of my ham radio license. I also keep a copy of the federal code that says that ham radio is not restricted from using in a mobile vehicle. So you may get pulled over by cops because he'll see you talking on something and he may think it's a cell phone. It's just, you're not going to get tested on that, but that's just for your own information. I did have a highway patrolman pull me over, and just he's walking up to the car, he goes, "Oh, are you a ham radio operator?" And he said, "I didn't notice your license plate." And I said, "Yes." He said, "Oh, sorry to stop you. I thought you were talking on a cell phone." And he didn't even bother me. He didn't even see my ID or anything.
Is that nationwide? Did you go to Nevada? They don't care what you got in your hand.
Well, that was a California highway patrolman that was nice to me and stuff. But he said, "Oh, he you know, because I have a call sign on my ham radio plate and stuff, and so he just didn't notice it when he pulled me over. But then he was walking, he went, oh."
Well, I can do it because it's federal law.
Mm-hmm. Yeah, it's federal law though. You can pull it up on the ARL website. You go to ARL, and they have it there. For a while, because they passed a law, they made it illegal about the cell phones. For a while, I heard there's a big thing about a lot of hams getting pulled over. But now it seems to have let up again, that they've gotten educated on it. Okay, yeah, don't get near any power lines. Don't get on any power poles and stuff like that. Occupational health and safety says you have to be a minimum of 10 feet. So if your antenna falls down, it's still going to miss hitting power lines by 10 feet. That's also code for firefighting too. You're not allowed to do any firefighting within 10 feet of energized electrical line. This okay, we'll talk about working on your own tower. The person up on the tower and the person down on the ground should have a hard hat on and eye protection. You're always dropping tools and stuff like that. For a lot of years, I used a fireman's belt, but they don't want you to do that. You can't, the crank up towers have to be, there's safety mechanisms have to be in place, has to be pinned, whatever the locking mechanism, you just can't crank it up and then climb up it. That would be the cable would be supporting it. That's not a good idea. Okay, they're gonna ask about a gin pole. What's a gin pole? A gin pole is that when you try to bring antenna structure up higher than the antenna, you'll set up a temporary pole with a pulley on top of it, so you can pull the antenna parts up higher than your level antenna. Then when you're done, you take that gin pole off and lower it back down. That's what a gin pole is. I know that that'll be on the test. 9, yeah. But okay, practice questions. That's it for electric. There's only going to be 2 questions on that. What's the safety hazard? 12-volt batteries, high current, stuff like that. There's also the problem with a battery is normal Lead acid batteries discharge hydrogen gas. Hydrogen gas is explosive. Everybody remembers the Zeppelin burning up. Well, if you spark that hydrogen gas, it'll blow apart your battery like it got hit by lightning. It cracks it apart. I saw it happen once. It just flashed a light and it was all in pieces. And then at the same time, it's splashing all that acid everywhere. So it's real dangerous. Discharging hydrogen gas is rough. So those are the dangers. Remember, it heats the tissue, goes in one way, comes out another. It can actually burn the tissue. Remember, green is ground on your wiring. Green is earth. Remember, green is grass. Safety ground. Now, it may not be an earth ground, but it'll be the chassis ground in the radio. Good way to guard against turn the power off. It's always the best idea. I know it's going to say that in here. Oh, I didn't say that. Oh, well. 3-wire cords, common safety ground, remember with the heavy straps and everything, GFI circuit. Ground all the protectors to a common plate, which is in turn connected to external ground. So everything's all connected to everything else. Whenever you have two conductors that aren't connected together, you have the chance for what's called potential. And if you remember your definition of what voltage is, electromotive force is the potential between the two. That's what creates voltage. When you climb on an electrical tower that's energized, you wear a Faraday suit. It's a wire mesh. And this is to keep you from developing a potential. So you wear this Faraday suit. You're like, a little electricity crawling through you. You need a fuse. It has to be fused. What kind of hazard might exist in a power supply that was turned off? You have the capacitors that still hold their energy. So you ground your capacitors. Best thing to do is disconnect from the power supply too. What members, should members where, anybody in the area should. You're either far enough away that something can't fall on you, you're like, I'd say the height of where the person's working, you should be that distance away. You don't need any safety equipment on then. If you're any closer than that, you need at least a hard hat and eye protection. Climbing harness, safety glasses. It's not safe without it. Watch out for other electrical wires. Don't have it fall on something. I had a guy once that he was setting something up on his roof and he touched the triplex, and the explosion knocked him off his roof, and he fell down between the fence and the wall of the house, which, sometimes that's only like 1.5 feet. He falls down in there. And we couldn't get him out of there. So we had to come in through the house and we had to breach the wall of the house to get him out of there because he managed to fall down there because the fence was another wall of another building and he had fallen down in there. And the electrical energy went through his shoulder and caused a real big injury and stuff, so he really got hurt. Pin pole is the device with a pulley that's taller than your tower. 10 feet. Same thing about firefighting. It has to be pinned and somehow pinned or locked in place. Oh yeah, or it's all the way down. So for a tower, they want you to ground each leg, and they're all grounded together. So that reduces the chance for potential. And it's all because when the lightning hits the thing, it creates all sorts of potential. Yeah, because they're not yours. They're private property, the utility poles. Oh yeah, there's my answer there. Yeah, you're not supposed to have any sharp bends in it. And maybe, oh, there it goes. Yeah, electrical codes control the actual physical requirements for an antenna tower. They also control how much power you run in your RF shack in your room and stuff like that if you're going to do any changes. Short and direct's always best. Non-ionizing radiation is what RF signals are. So anything over 50 watts, they want you to get checked out. But it also has to do with that 30 to 300 megahertz range. They're real worried about that area in there, especially 6 meters. Distance from the antenna decreases RF exposure, radiation pattern. Yeah, this is what I was talking about, is that we happen to be the right size for 50 megahertz because of our general size. And so we absorb more energy at those type of things. HF, we're too small. Microwaves are too big. There's a big complicated formula that's Bolton 65, and you can do the computer modeling and stuff too. And but that's only if you're going to go to high power levels. They'll get an RF burn. This is actually a big consideration when they have field day, when there's units out in the field and they're setting up temporary antennas and things like that. You have to make sure that they're up high enough, nobody can reach them or touch them or anything like that. If you're using verticals, so that you're going to have to put up a temporary fence around them and things like that, so people don't touch them. Relocate antennas if you think it's too much RF exposure. You don't want to set up your beam and point it at your house and stuff like that. and then hook up 1,000 watts to it. Although there's a lot of discussion right now with that they've been doing that to the embassy, huh? They've been.
There's like the Russians, I think, were basically they think you have radio to zap like embassy staff.
Yeah, and the Cuba embassy was doing it too, and stuff like that. They're giving them RF exposure because they're getting headaches and stuff like that. Yeah, pretty weird stuff. I wonder if they're using 6 meters. Because we're most vulnerable to 6 meter, 54 megahertz frequencies. Yeah, anytime you do any kind of change, like you get a brand new radio and the radio you used to have was 50 watts and you were under the controls, but now you went to a 150 watt radio, maybe better reevaluate your situation. Duty cycle is the amount of like the average exposure, the amount of like the time that you actually get the radiation. That's what's important for that. Yeah, just how long it's transmitting for. You either cut down your transmitting cycle or you cut down the power levels. That's how you stay safe. Well, that's good to know. Can't do genetic damage. This is a copy of the exact question and everything. So, okay, so we're gonna figure it out here. Average time for exposure is 6 minutes. How much power density is permitted if the signal is present for 3 minutes and absent for 3 minutes rather than being present for the entire 6 minutes? Well, you can be exposed to it twice as much. because you cut down the exposure time to half. 2 times as much. And that's that. Okay, now we're going to go to my other. We're just going to go over questions now. Let's see here. Okay, so these are all section T0. These are the actual questions. Okay, which of the following is a safety hazard of a 12-volt battery? This is all going to be repetition of the stuff we just went over. Okay. Touching both terminals can cause electrical shock? Yeah, but so. Shorting the terminals can cause burns, fire, and explosion? Yep, probably so. RF emissions from the battery? Nah. All of these choices are correct. It's not C. I don't think, where'd they get the, oh, okay, that's the only one. Well, I don't know. I think you still get burned. Okay, it's just B, I guess, on that one. What health hazard is presented by electrical current flowing through the body? It may cause injury by heating tissue. Yes. It may disrupt the electrical function of cells. Sure does. It may cause involuntary muscle contraction. Yeah, okay, all these are correct. The United States was connected to the green wire. Ground. See. Green is ground. What's the purpose of a fuse? Well, the joke is always that a 30-cent fuse will stay intact so your $400 stereo can burn up. You know, the stereo will protect that fuse. So anyway, a fuse. Case of overload. Yeah, that's probably the answer. To limit current to prevent shocks. Must be B. It's a weird way to say it, though. Why is it unwise to install a 20 ampere fuse in place of a 5 ampere fuse? Excessive current would cause a fire. For an emergency, you could use a 2 amp fuse, but maybe it would just blow. You could use a lower powered fuse in a real, everybody's done it in their car where they didn't have the right fuse, put in the lower one. Yeah, just don't put a penny in there. What's a good way to guard against electrical shock? 3-wire cords, we like that. Connect all AC power equipment to a we like that too. Use a circuit protected by ground fire. We like all of those answers. Okay, here's a lockout tag. You're working on the circuit. This actually would be a good idea at my house because I'd be like pulling the power in my room to work on something like that, and the wife would come along and just turn it back on again. So you use a lockout. These are forms of lockout. Not an idea. Which of these precautions should be taken when installing devices for lightning protection at coaxial cable feed line? Include a parallel bias switch for each protector so that it can be switched out of the circuit when running high power. I don't know about that. Include a series switches and ground line of each protector. Yeah, I like D also. What safety equipment should always be included in home built equipment that is powered from 112 V AC power circuits? Use a circuit breaker. Yeah, we like that. Now we don't need a voltmeter. Inductor. Now we don't need that. Now we don't. Fuse is what's going to save you. Okay, what should be done to all external ground lines or earth connections? As possible. Nope. Bond them together with heavy wire conductor. We like that. Doing them for residents. Nope. Bond them together. What can happen if lead acid battery is charged or discharged too quickly? Give off flammable gas or explode. Voltage will not become a reverse on a lead acid battery. It has to be A. Remember, hydrogen gas. What kind of hazard might exist in a power supply when it's turned off and disconnected? You know this one. It's got to have capacitors in here somewhere. There it is. D. Oh, what happened? Turned off and disconnected. It's got to be D. I think this one has it wrong. What the heck? Okay, 10 safety. Okay, so far, any questions? So far, so good? Okay. When should members of a tower work team wear a hard hat and safety glasses? At all times when any work is being done on the tower. We like that. C. What is a good procedure to observe before climbing an antenna tower? Grounded wrist strap. You only need that if you're wearing the Faraday suit. Grounded wrist strap. Remove all time. No. Put on a carefully inspected climbing harness, fall arrested. This is the longest answer, the right one. Remember that one in college, you know? If the longest answer is the right one, you always check that one out. So let's see. Under what circumstances is it safe to climb a tower without a helper or observer? Okay, I got another question on this. Is it okay if your dog watches you? Is that a because I've done that a couple of times. The dog was a safety person. D, never. There's a rated climbing harness. That's what they want you to wear if you're doing any tower work. They're a lot more comfortable now than they used to be. Okay, which of the following is an important safety precaution to observe when putting up an antenna tower? I like C here. Look for and stay clear of any overhead electrical wires. Remember, 10 feet. Occupational health and safety says 10 feet. How far can you jump down without major injury?
3 feet.
Yeah, under 10 feet. At 10 feet, 50% chance of a major injury. Just 10 feet. So that's why you always got to tell firemen, don't jump off a roof, because they'll do it all the time. They get in a hurry. They won't wait for a ladder. They'll jump off a roof. Don't do it. Break your hip or something like that. 10 feet. It's not very much at all. Shows you how fast we accelerate coming down. Gin pole. Hey, here's our gin pole question. Yeah, lift tower sections or antennas. It's just that thing they put up there temporarily. Just has a pulley on it. And we've all had to put up antennas where we didn't have a gin pole. And that's hard. Oh. What happened here? Okay, then remember I was talking about that where if it were to fall, it doesn't come within 10 feet. Stay away from energized lines 10 feet. Triplex is a big one to stay away from. Stay away from triplex because the insulation on triplex is always worn off. It's always falling off. Which of the following is an important safety rule to remember when using a crank-up tower? Type of tower must never be painted. It can be painted. Type of tower never. Of course, you're going to ground it. It must never be climbed unless it's in a fully retracted position. That's it.
You guys come out to the field day this month. We have a crank-up tower. Let's see what he's talking about. It's just a cable that just runs up the middle.
Yeah, it just runs up the. Yeah. It holds the antenna up okay, but it's not supposed to take any more weight than that. What is considered to be a proper grounding method for a tower? Now we don't like A. B is out. Separate 8-foot ground logs for each power leg bonded to the tower and each other. We like that. That's it. Tower base on a cold water pipe. Oh. Why should you avoid attaching antenna to a utility pole? Yeah. The antenna could contact high voltage power wires. That's why. It's private property too. You got to stay off. Which of the following is true concerning grounding conductors used for lightning protection? It doesn't matter if it's insulated or not. No. Sharp bends must be avoided. There it is. See. One of the very first cities that was electrified was Bodie in California. And they set up a generator or something like that in the 1800s, and they didn't know anything. They were going to set up street lighting with electricity. They didn't know anything about electricity. And the same thing is they were so scared about it, they made sure there weren't any right angles to the power thing. So all the power poles you see go like this and stuff like that. In the 1800s, they didn't know. I even want to say, I think it was a DC generated system. That was Tesla's gift to the world, was to convince Edison to go to AC. Let's see, which of the following establishes grounding requirements for amateur radio tower antenna? I think it's B, local electrical codes. Because it's a physical system for lightning arrested stuff. Which of the following is good practice when installing ground wires on a tower for lightning protection? Put a loop in the ground. What's that? Make sure that all bends are clean, right angle bends. Ensure connections are short and direct. We like C. Connections are short and direct. What's the purpose if a safety wire through a turnbuckle used to tension guidelines? Okay, everybody knows what a turnbuckle is. It's a tightening device. They have two rods going into it and they turn it like that. Tightens up wire, stuff like that. So they're asking if you have a safety in there. What it does is it prevents loosening of the guy line from vibration. It just goes right through the turnbuckle to make sure it doesn't untwist. You also can use what's called an egg insulators on antennas. And the advantage of an egg insulator is if it breaks, the line doesn't fall. Because if you use a dog pone type insulator, it breaks, the line falls. If you use an egg insulator, there's two holes like this, it'll just fall onto itself. It won't actually come down. Preventive loosening of the guideline. RF hazards. Non-ionizing radiation. They told you guys this enough times. Which of the following frequencies has the lowest value for maximum permissive exposure limit? Oh, nobody better miss this one. 50 megahertz. That's right. Because we're wavelength at 50 megahertz. There's the chart. Everything. 50 megahertz is right, like right there. What is the maximum power level that an amateur radio station may use at VHF frequencies before an exposure evaluation is required? This 50 watts. That's at VHF frequencies. I think HF is 300 or something like that. It's pretty high. What factors affect the RF exposure of people near an amateur radio station antenna? Frequency and power level, yeah, distance, radiation pattern, all those are correct. Because you have some beam antennas, like microwave dishes and stuff like that, you know. I wonder if those Cubans that were doing that to the embassy personnel, if they were ham radio guys, they knew about this. Why do exposure limits vary with frequency? Lower our frequency, no, that's not true. Lower our frequency. There it is. Human body absorbs more RF energy at some frequencies than at others. It has to do with physical size. Because we're a bag of salt water, right? So it's our physical size. I suppose dogs are more susceptible to higher frequencies because they're smaller. Cats are probably up in microwaves. Which of the following is an acceptable method to determine that your station complies with FCC RF exposure regulations? By calculation based on OET Bulletin 65? Yes. By calculation based on computer modeling? Yes. By using a field strength meter? Yes, we like all those answers. Okay? What could happen if a person accidentally touched your antenna while you're transmitting? Cause television interference. Yeah, probably receive RF burn. Yeah. Which of the following actions might amateur operators take to prevent exposure to RF radiation in excess of FCC supplied limits? Relocate the antenna. Relocate the transmitter. Increase it. No, I just think relocate the antenna is the only right one here. Relocating the transmitter ain't gonna do nothing. How can you make sure your station stays in compliance with RF safety regulations? FCC is not going to care. Reevaluation the station whenever change. I think the answer is B. If you change equipment, especially if you go to higher power equipment, or you get into direct antennas, then you may have to reevaluate what you're doing. Why is duty cycle one of the factors used to determine safe RF radiation exposure levels? It affects the average exposure of people to radiation? Yes. It affects, no, it's A. It affects the average exposure of people to radiation. That's a time factor. Was the duty cycle during the averaging time for RF exposure? The antenna transmitter is actually transmitting. C. We don't care if it's off. It can be off forever. How does RF radiation differ from ionizing radiation, radioactivity? Doesn't cause genetic damage. Hey, this is an exact question. If the averaging time for exposure is 6 minutes, how much power density is permitted if the signal is present for 3 minutes, absent for 3 minutes, rather than being present for the entire 60 minutes? So that means that you can do that system twice as long. So 2 times as much. And that's it. Okay, any questions? I want to thank everybody for getting this far and getting their ham radio license. Every ham radio licensee that we get is an asset to the community. Everything. I moved down here from Missoula, and sometimes the storms come through there, and radio is all it works. So you help the community out a lot by becoming a licensed ham operator.
Around here, there are a lot of places where cell phones don't work. And it was actually a couple of years ago, coming down 14. I was on a field trip with students, and I had a little balcony. And we're at your mile marker 15, and there's no cell service. Came around the corner, we had an accident, and it just happened. I was actually showing a student how the radio worked, ironically. I was on the Blowhard Creek talking Sunday in Las Vegas, and came around the corner, saw the accident. I actually was a passenger. I got out, walked up to the accident, and was talking. Actually, got somebody in St. George, and they called emergency services. Emergency services was there within 15 minutes. And I checked from down the hill. It was 20 minutes until my cell phone. And so it turned out that the one that was found out who I was and actually came and thanked me. His leg was broken. But he came and thanked me and said, yeah, you saved my life because of that ham radio. So you're exactly right. Having one of these things helps people, not even, could be yourself, but other people in situations where
Did you have a regular red hand or did you?
I've but we were probably half a mile from Boulevard. But having that radio basically saved someone's life.
All right, Brian, I'm gonna go up to the upper level and run this wire down through the wall. Grab your walkie. I'll call you when I get up there. Okay. Brian, pick up. Over. What? Brian, please say over when you finish talking. Over. What? Over? Do you see the wire yet? Over. No. No.